All right, today in geometry, we're going to finish up our probability. So we're looking at section 12.3, permutations and combinations. Our essential question, how are permutations and combinations useful when finding probabilities? After today, you should be able to use permutations and combinations to find the number of outcomes in a probability experiment. So let's start with number one. Manuel wants to advertise the number of one-topping pizzas he offers to his customers. How many different one-topping pizzas are available at Manuel's Pizzeria? And so then we see in the chart over here, you can choose a size, then you can choose a crust, and then you can choose a topping. So we're going to make a tree diagram. So if I make a tree diagram and I start out, here's our pizza. So I can get two different sizes. I could get large or medium. So we start with our size. And then I could get two different types of crust. I could get deep dish or thin. So this is our crust. And then each one I could get one topping, sausage, pepperoni, or cheese. So sausage, pepperoni, or cheese. Same thing here, sausage, pepperoni, or cheese on all of these. Same thing over here though. All right, so now add up how many different possibilities do I have. So I would do the size times the crust, and these are toppings, times my toppings. So my sizes, I have two different sizes, I have two different crusts, and I have three different toppings. So 2 times 2 gets me 4, 4 times 3 gets me 12. So I have 12 different options available. This example illustrates what's called the fundamental counting principle. So the fundamental counting principle. Which states if there are m ways to make the first selection and n ways to make the second selection, then there are m times n ways to make the two selections. If a third selection p is added, then there are m times n times p to make all three selections, and so on. The car that Miss Garcia is buying comes with a choice of 3 trim lines: standard, sports, or luxury, 2 types of transmissions, automatic or manual, and 8 colors. How many different option packages does Miss Garcia have to choose from and explain? Okay. So if we use the fundamental counting principle, okay, there are 3 trim lines times 2 transmission types times 8 color choices. So all we have to do is do 3 times 2 times 8. So 3 times 2 gets us 6, 6 is 8, 48 different options. Now we want to talk about something called the factorial. The factorial of a positive integer n is the product of all positive integers less than or equal to n. It is written as n, and then that exclamation point is read as factorial. And so it just tells us, and read as n factorial. So by definition, 0 factorial is equal to 1. So n factorial would equal n times n minus 1 times n minus 2, dot, 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 and then times 2 times 1. So number 3, Gabriella is making a playlist with her 3 favorite songs. How many possible orders are there for the songs? So first we're going to make a list. We'll call the songs A, B, and C. So let's look at the order. So we could do A, B, and C. Then I could change the A and B and make it B, A, and C. And then I can change the C and make it C, A, and B. So then up here, A, B, and C, I could switch the B and the C, and so make that A, C, B. Here I could switch the A and the C and make this B, C, A. And finally, CAB, switch the A and B and make it CBA. So we see that there are 6 different choices. Method number 2 would be use the fundamental counting principle. So there are 3 choices for the first song. times, now there's 2 choices for the second song, and finally 1 choice for the third song. So that gets us 3 times 2 times 1, which is still 6 choices. Then we could use factorials. So 3 factorial, and this is where in class I will show you how to do this in your calculator. So your calculator will do this for you. You'll find the factorial button. Again, that looks like that exclamation point. So you would type in 3 and then that factorial button, and it will tell you that it, again, is 6 choices. Right, so let's look at number 4. Gabriella wants to make another playlist using 5 of the 8 songs from her favorite artist's latest album. How many playlists are possible? Okay. So again, if we look at the fundamental counting principle, okay, so on the first song, she has 8 choices. On the second song, now she has 7 choices. On the third song, she has 6 choices. The fourth song, she has 5 choices. The fifth song, she has 4 choices. We're only looking at 5 of 8 songs, so we only need 5 spaces there. So if we multiply all of these together, 8 times 7 times 6 times 5 times 4, we would get 6,720 playlists to choose from. If we wanted to do this one by factorials, okay, so there were a total of 8, so 8 factorial, but that will get us 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, but we don't want all of that because we're only looking at 5, so then we would have to do 8 minus 5 down here, factorial, which would give us 8 factorial over 3 factorial, and that would get us the exact same answer, 6,720. So now we're going to talk about, these actually have some special connotations. So we're going to talk about what's called a permutation. A permutation is an arrangement of some or all objects of a set in a specific order. So it's a permutation if it's a specific order. The number of permutations of n items arranged r items at a time is, our notation, we have the capital P, and we have subscripts of an n and an r. That's going to equal n factorial divided by n minus r factorial, as long as r is between 0 and n. Then we have what's called a combination. A combination is a set of objects with no specific order. The number of combinations on n items chosen r at a time is the capital C with subscripts n and r on either side. That equals n factorial divided by r factorial times n minus r factorial, as long as r is between 0 and n. And again, this combination and this permutation, I'm going to show you in class how to do that on your calculator. Your calculator has those as well. So let's look at another one. So number 5, Marisol is planning to be a counselor at summer camp. She can choose 3 activities for her session. How many different combinations of 3 activities are possible? So in this situation, the order of 3 chosen activities does not matter. A group of 3 items can be arranged in 3 factorial ways. So you must divide the number of permutations by the number of arrangements of the chosen items. Therefore, we have a combination. So if we count up over here, we have a total of 10 activities. So there are 10 total activities to choose from. So if we're doing a combination, because the order doesn't matter, so I know capital C. So how many total do I have to choose from? I have 10, so that's my first subscript. How many do I want? Okay, we're choosing 3, so that's my next subscript. So that is equal to, okay, so I can plug this into the calculator, 10 combination 3, and it's going to give me the answer. But I'm going to show you how it gets that. So in case you didn't have a calculator that would do this, so this is equal to, the formula says 10 factorial over 3 factorial times 10 minus 3 factorial, which is 10 factorial over 3 factorial times 7 factorial. So on top, 3 factorial, that is, let's see, 3,628,800 over 3 factorial times 7 factorial is 30,240. I divide that, I get 120. So there are 120 combinations of ways to choose 3 activities where order doesn't matter out of those 10. So now it says, how many ways can a camper choose 5 activities from the 10 available at summer camp? Again, order does not matter. Therefore, we're doing a combination. I still have the 10 to choose from, but this time I'm choosing 5. So this time we're going to put this in our calculator, and our calculator tells us it's 252. All right, so number 7, a teacher chooses 5 students at random from the names shown to work together on a group project. What is the probability that the 5 students' names begin with a consonant? So first, does the order matter? No. Therefore, we will use combinations. So again, I need to look at how many total students do we have. So if we add up all of these, we have 18 total students. So I want to look at how many start with a consonant, okay? Well, first, we're choosing 5 students, okay? So if I look at the total number of outcomes, just the total number of outcomes, that would be 18 combination of 5. Again, we're going to plug that in our calculator and find out that's 8,568. Now we're going to look at the number of outcomes whose name starts with a consonant. So if we count up over here, everyone that starts with a consonant, we have 13 of them. So now I'm going to look at, there's 13 ways, a combination of choosing 5. That's 1,287. So if I'm looking for the probability that their name starts with a consonant, it's the number of consonants over the total number of outcomes. So the total number of consonants was the 1,287 over the total number of outcomes was 8,568. Divide that out, we get 0.1502, or approximately 15%. So the probability is about 0.15 or 15% that 5 students' names will begin with a consonant. So now same data, but now we're going to find what's the probability that the 5 students' names end with a vowel. So we're going to count up how many end with a vowel. There are 12 total that end with a vowel. We already know from above that we started out with 18, and we're choosing 5. Our total outcomes were 8,568. So now I want to look with the vowel. There's 12 to choose from. I'm picking 5. Combination, again, the order doesn't matter. My calculator tells me that's 792. So the probability that they end with a vowel, n is the probability of the vowel, 792, over the total outcome, so that was 8,568. Divide that out, we get 0.0924, or approximately 9.24% of 5 students' names being randomly chosen that end with a vowel. All right, so that is our last section of probability, our last lesson that we're looking at before our EOC test. Our homework today is again on Envision 12.3, practice and problem solving. And then after this, we will just start working the EOC practice test together step by step.